Imagine every step you take, every car that passes, every gust of wind generating power. What if our cities could literally power themselves, silently transforming urban motion into clean electricity? Today, we're diving into the groundbreaking concept of the human dynamo, where your daily commute becomes a renewable energy source. Our cities are constantly in motion, a symphony of activity that never truly sleeps. Millions of people walking, cars and buses flowing through streets, trains rumbling underground. All of this movement creates an incredible amount of kinetic energy. But here's the crazy part. Almost all of it is completely wasted. It just dissipates into the environment as heat and sound. Think about the sheer scale. A busy subway station sees hundreds of thousands of footsteps every single day. A major highway handles tens of thousands of vehicles per hour. This isn't just background noise. It's a massive, untapped reservoir of power hiding in plain sight. But what if we could capture that energy? What if we could turn our bustling public spaces into a silent, ubiquitous power plant? This is not science fiction. It's the next frontier in sustainable urban development. Get ready to discover how innovative materials and ingenious infrastructure are making this a reality. So how do you turn a simple footstep into electricity? The magic lies in a few key scientific principles, starting with something called piezoelectricity. You might have heard of it. Piezoelectric materials are special crystals and ceramics that have a unique property. When you squeeze them, or put them under mechanical stress, they generate a small electric charge. Now, imagine embedding these materials into tiles under the pavement. Every time someone steps on a tile, they compress the material, creating a tiny spark of electricity. One step doesn't do much, but multiply that by thousands of pedestrians in a busy city square, and suddenly, you have a continuous stream of power. It's literally harvesting energy from the ground we walk on. But the innovation doesn't stop there. Meet the new kid on the block, triboelectric nanogenerators, or TNGs. These are even more exciting because they can be made from common, flexible materials like plastics and fabrics. TNGs work on the principle of static electricity, the same thing that makes a balloon stick to your hair. When two different materials rub together or separate, they exchange electrons, creating an electrical potential. TNGs are designed to maximize this effect on a tiny nanoscale. They're incredibly sensitive and can generate power from the most subtle movements, a light footfall, so the sway of a building in the wind, or even the vibrations from passing traffic. Their potential for being integrated into almost any surface makes them a game changer for urban energy harvesting. And what about our busiest roads? That's where electromagnetic induction comes in. This is the same principle that powers most of the world's generators. When you move a magnet past a coil of wire, it induces an electric current. Now, imagine embedding systems under the road surface. As cars, with their heavy metal bodies, pass over, their movement interacts with magnetic fields, pushing and pulling on generators to produce electricity. In this way, a busy highway isn't just a route for transport. It becomes a linear power station, generating clean energy from the constant flow of traffic. With this science in hand, we can start to reimagine our entire urban landscape. Think of our cities as potential energy farms. We could have kinetic pavements seamlessly integrated into sidewalks, parks, and plazas. Picture Times Square or Shibuya Crossing, not just as iconic landmarks, but as massive power generators fueled by millions of tourists and commuters. Every step taken to catch a train or meet a friend could help power the streetlights or a nearby charging station. Bridges are another perfect candidate, and they are constantly vibrating from traffic and swaying in the wind. By equipping them with piezoelectric sensors and small wind turbines, we can turn this structural movement into a reliable source of electricity. The bridge becomes more than just a crossing. It becomes a dynamic energy hub, contributing to the grid just by doing its job. And let's not forget our public transport hubs. Train stations, bus stops, and airports are epicenters of human movement. The constant flow of people, the braking of trains, the opening and closing of automatic doors, it's all kinetic energy waiting to be harnessed. Installing energy harvesting floors in these high-traffic areas could generate a significant amount of electricity, potentially powering the station's own lighting, ticket machines, and information displays. These hubs would become models of self-sufficiency. This isn't just a futuristic dream. It's already happening. We're seeing real-world examples pop up around the globe. In places like London and Tokyo, companies have installed kinetic floor tiles in busy pedestrian areas as pilot projects. One famous installation at a London shopping center powered overhead lights from the footsteps of shoppers. A nightclub in Rotterdam even used a kinetic dance floor to power its own lighting system, literally fueled by the energy of the dancers. While these are small-scale demonstrations, they are crucial proofs of concept. They show us that the technology works and give us a glimpse of what's possible when we scale it up. Now, let's project this forward. What are the long-term implications for our cities? The biggest is a move towards true energy independence. Imagine a future where neighborhoods or even entire city districts are partially powered by their own activity. This creates a more resilient and decentralized power grid, less vulnerable to large-scale outages. It reduces our reliance on fossil fuels and helps us meet our climate goals right at the local level. This leads us to the ultimate vision, the human dynamo city, a fully self-sustaining urban ecosystem where every movement contributes to the collective good. The city wouldn't just consume energy, it would produce it in a silent, symbiotic relationship with its inhabitants. The very pulse of urban life, the rhythm of our daily routines would become the heartbeat of a living, breathing, self-powering metropolis. It fundamentally changes our relationship with our environment. We would no longer be just passive consumers, but active participants in powering our world. Of course, we have to be realistic. There are significant challenges on the road ahead. Right now, the cost of these technologies is still high. Manufacturing piezoelectric tiles or advanced TNGs on a massive scale is expensive. We also need to improve their efficiency and durability. A pavement tile has to withstand millions of footsteps, extreme weather conditions, and the general wear and tear of city life for years to be economically viable. Beyond the technology, there's the monumental task of infrastructural overhaul. Ripping up existing sidewalks and roads to install new systems requires immense investment. Planning and coordination between city governments, private companies, and the public. It's a huge undertaking that can't happen overnight. But despite these hurdles, the potential is undeniable. The concept of the human dynamo offers a powerful vision for a truly net-zero urban future. It will require a collective effort from scientists developing better materials, to engineers designing smarter systems, to city planners brave enough to invest in this future. And it requires us, the public, to embrace this change and see the power in our own collective movement. The path to a self-powering city is long, but the first steps have already been taken. The next time you're walking through a busy street, just imagine the energy all around you. It's a reminder that the solutions to some of our biggest challenges might be right under our feet. Thanks for watching. If you're fascinated by the future of our cities and sustainable technology, make sure to like, subscribe, and hit that notification bell so you don't miss our next video. See you next time.